Okay, these are the steps we're going to use. Actually, we're going to use in example 2. This is at the top of page 143. So here's what we're going to do. We're going to write each equation in a form that is easy to graph. For most of us, that it looks like this. Y equals mx plus b. Now, the next thing we're going to do after we've done that is we're going to graph both equations in the same coordinate plane. Sounds pretty easy. Then what we have to do is, now watch this word estimate here. This is kind of important. We're going to be estimating the coordinates of the point of intersection. Now, I believe in the first page we probably called that the solution. And I had you skip this, but point of intersection is a good enough word. It's pretty easy to understand. It's where the lines cross. And then the last thing we're going to do in step 4 is we're going to check. So we're going to check by what we did in the previous example was we're going to check the solution by substituting them into the equation of the original linear system. In other words, the original equations. Okay, so now this is example 2, and I will move fast through some parts of this, but you can always ask questions or rewind it if you miss some of the algebra steps. Here we go. So what we have is we have two equations. We have this one and this one. Now with these equations, what we're going to do is we're going to put them in something that's easy to graph. The easiest thing for us to graph is probably the slope-intercept form. So here's what we do. To get y by itself on equation 1, we're going to minus 5x on both sides, or minusing 5x. And here's what's left. We got a negative 5x and a negative 12 on the right side. Okay. Now I'm going to mentally do this. We're going to divide by 4, divide by 4, divide by 4. Here's what we have. If we divide by 4 here, we have negative 5 over 4x minus, and again, we're going to divide by 4 here, we're left with 3. So this equation should be y equals negative 5/4 x minus 3. Going over to equation 2, we're going to take away that 3x right there. Okay, we're going to subtract that. So we're going to subtract 3x. We're left with negative 4y. And then over here, that negative 3x is going to go right here. We're going to slip it in there because we like slope-intercept form. We're going to divide by 4, or I'm sorry, divide by negative 4 everywhere, here, here, and here. And you're left with positive y. Here's going to be 3/4 x. And right here is going to be positive 5. So it should read as y equals 3/4 x plus 5. Okay, now pause the video while you graph both of these equations. Go ahead and pause the video and then graph both equations. And by the way, what might help you on the first one here is to think of this as a 5 over negative 4. It'll be easier to graph on the graph. If you think of this as 5 over negative 4, 5 over negative 4, which doesn't change it at all, 5 over negative 4. And then hopefully this is what you got here. If you graph this on another sheet of paper, it's a little bit easier. So again, you can pause to do that if this graph right here doesn't work. But here's what I've got. It looks to me like it crosses at negative 4, positive 2. So I'm going to type that in here real quick, and I'm going to type negative 4, positive 2, because that's where I think it crosses. And I'm going to check whether negative 4, positive 2 works by substituting that point, negative 4 for the x and positive 2 for the y. So what we're going to do is we're going to put the negative 4 right here. We're going to put the 2 right here. And then we're going to put a negative 4 all the way over here. And a positive 2 here. And check if those work. Go ahead and pause and check if those work. Now for me, they both worked. I got 12 equals 12 on equation 1, and then negative 20 equals negative 20 on equation 2. Because negative 4, positive 2 does seem to work in both of these, we're going to say that negative 4, positive 2 is the solution of the linear system.